In this video, I'm going to explain how do we develop a program using Lab 5 Task 4 as an example. And this program involves a for loop. Okay, so let's take a look at what is the requirement given in this question. This question asks us to write an M file which creates an n by m matrix with elements that have the following properties. An example is given down here so we can understand the requirements we've referred to this example. So the first requirement says that the value of each element in the first row is the number of the column. So that refers to this part 1, 2, 3, 4, 5 because column 1 then the value is 1, column 2 the value is 2 and so on until column 5 the value is 5. Okay, so that is easy to understand. Second requirement, the value of each element in the first column is the number of row. So that means this is in first column, first row therefore is 1. This is second row, therefore is 2. Third row, therefore is 3. Until the fifth row, therefore this is 5. Okay, so this part is still easy to understand. And the last requirement, the rest of the element each has a value equal to the sum of the element above it and the elements to its left. So let's check and see. If I'm going to look at this element, so sum of the element above it, above this I have 2, and the elements to its left only these 2, therefore 2 plus 2 we get 4. Okay, seems okay. Okay, next let's do a check again based on this. It says that it's the element above it and the elements to its left. So the element above it is 4 and the element to its left is 3. Therefore the value of this location is 3 plus 4 we got 7. Okay, so by looking at this example, we can quickly understand the requirements. Because this example is already given to us, therefore, when we develop this for loop, we do not need to do any manual calculation. We can understand the requirement based on the example given and straight away start to develop our program. And next is the question says, the M file should prompt the user to enter the values for n and m, which is the dimension of the matrix. So the example given to us is a 5 by 5 matrix. Okay, so let's take these requirements and copy and paste them into the MATLAB editor so that we can develop the steps to write the program. So just in case I will need it, let me just take this part as well. Okay, copy paste everything into MATLAB and use Ctrl R to make them a comment. So let's start to develop the steps based on the requirement given here. So the first requirement says write an M file which creates an n by m matrix. Okay, so the first step would be create an n by m matrix. Okay, and this n by m matrix need to meet these 3 requirements. So let me put them into the documentation as well. Okay, so I have done with this part with elements that have the following properties. Okay, so this I have documented this entire thing as the first step. Let's look at the next step. The M file should prompt the user to enter the value for n and m. In this case, obviously, this step should happen before we create the n by m matrix. Therefore, we have identified that the first step should be prompt the user to enter the values of n and m. Okay, so I have documented this step, which is the dimension of the matrix, so that is fine. And this is the output. So let me just add some spacing so that this value looks easier to read. we'll see if we are going to refer to them later on as we develop the code. Okay, looks like this program only involves two simple steps. Okay, let's write the first step. Then we look into how do we develop the code for the second step, which involve a for loop. Okay, the first step says prompt the user to enter the value of n and m. So it's given in the question that this is a n by m matrix. So that means the value of n is the number of row and the value of m is the number of column. So we should prompt the message in this way so that the user understand what we mean. So n is equals to input, please enter the number of rows. Okay, and m will be the same thing, but I'm going to ask the user to enter the number of columns. Okay, so this is what we need in the first step. So if you would like to give it a try, you can run this code now. Okay, this is lab 5. Let me double check what task is this. This is task 4S. Okay, enter the number of rows. Let's say if I put 5 rows and enter the number of columns, I say 5 columns. Okay, so we can see here n and m both has the value of 5. So these two line of the code works well. Let's move on to the second step. Create an n by m matrix which meets this requirement. Now, if we study the pattern that we have seen here again, if we are going to use a loop to create this matrix, that means we will be repeating the same steps multiple times. But we notice that what we have in the first row as well as the first column doesn't really match with the calculation that is required by the other elements. Okay, so this tells us that we need to create the first row and the first column outside of the loop, and the rest of the element can be handled inside of the loop, because the loop will only repeat the same procedures. Any calculation that is different or special, we will have to do them outside of the loop. And usually this special calculation will be done only one time. Therefore, it's worth to do it outside of the loop. Okay, the first step that I'm going to do is create the values for the first column. Okay, and after that, I will create the value for the first row. Then only we go into the loop and create the rest of the values. Okay, the reason that I'm going to create column first, because if I have created the first column, later on it's easier for me to append or add additional elements at the right hand side of the first column. So I will create the values for the first column as well as the value for the first row before I start the loop. So that would be the first step. And I will create the first column. Okay, it is easier to write the code if we create the column first and later on append or add the values to the right hand side of the first column. Okay, so let me create the first column, and I will use a variable called myMat, which represents my matrix, equals to the first column is just the row numbers. So how many rows do I have? That depends on the user input. Therefore, I will start with the value 1. We can see that it always starts with the value 1 until whatever number of rows that the user requests in the input. So it will be 1 until n. Okay, so because if I create the code like this is a row vector, I will just transpose it so that it becomes a column. So I can run this code and see if it is correct. Now let's say if I try with 7 rows and 4 columns, then check what is the content of my mat. So it looks like correct because I have input 7 rows, and now I have the row number for 7 rows, 1 to 7. Okay, so next I'm going to work on how to create the first row. Okay, in order to create the first row, I already have the first column, so I just need to add the remaining values. So this is already part of the first column, so when I add the value or append the value for the first row, I can start from 2. So I know that now the code will start from 2. So until where it will end, that depends on the user input, depends on how many number of columns the user want, which is m. Therefore, this will be 2 to m. Okay, now the next thing is now I want to append this to only the first row of the matrix. Therefore, I'm performing inserting the numbers into a matrix. Therefore, I will be having the matrix name, the variable name, equals to these elements that I would like to insert, and I need to perform matrix addressing at the left hand side of the equal sign if I want to insert a value. Okay, these values will be inserted into the first row, therefore is 1. So insert into which column? I'm going to insert it into column 2 until column m, whatever the number of column the user entered. So let's check also if this code works correctly. Let me run this now. I will try with 3 rows and 5 columns. Okay, so let's check my mat. I have 3 rows, 1, 2, 3, and the number of columns, I have 5 columns. So it shows that I have written the code correctly. Okay, next, I will be creating the rest of the elements. Okay, so now let's take a look at this example to help us to identify what would be the rest of the element. So because I already have the first row and the first column, so after that, what I need to create in the loop will be this value. Okay, and this value in terms of the position in the loop, it is actually position 2, 2. So in order to help us to understand how the position value changes, let me duplicate this and replace this with the position value. So this number is actually position 2, 2. Okay, and if we can choose to go column by column or row by row. So let's say if we choose to go for column by column, that means I will create all the value in the first column, then only the second column. Okay, so this will be the first column that I will need to work on. So the first number is 2, 2, and this number here is in row 3, and then the column number is still 2. Okay, and this number will be row 4 and the column number is still 2. And this number will be row 5, the column number is still 2. Okay, so this is how I would be able to understand how the row number and the column number changes. So for the first column, the row number changes from 2, 3, 4, 5 until whatever value the user entered. This is equivalent to the number of rows. Okay, so the number of rows is n. Therefore, until n. and this will tells me that this value here at the end, it will be n of column 2. Okay, and let's look at how what will happen when we move on to the next column. When we move on to the next column, I will start with row 2 again and column 3. Okay, this is in column 3. Okay, and the next value below it will be in row 3, column 3. And same thing, we are going to have row 4, column 4, and row 5. Sorry, this is row 4, column 3, and this is row 5, column 3. Okay, so this value here will be also until n. Okay, and we can continue to investigate this pattern until we settle all the columns. Now we have understand how the value changes in the row number. Okay, so the column number for column 4, if it is column 4, then the position of this element will be in the second row and the fourth column. Okay, and if it is the next column 5, this element will actually be second row, column 5. So we can see from these elements that how many column depends on the user input, which is the number of column is m. So I know that this will goes all the way until second row, column m. Okay, let me make a bit of adjustment so that we can see the pattern clearly. Now, if you still don't understand, you can of course continue to replace all the elements with the position number and helps you to understand the situation better. So now based on this, we can see that because I need to run the row number from 2 to n, and I need to run the column number from 2 until m. So this tells me that there is a fixed number of rounds or fixed number of iteration that I will need to run, and therefore it tells me that a for loop is suitable for this case because we know how many number of rows and how many number of columns from the very beginning of the program. Okay, so the first element will always start from 2 2 inside the loop because outside of the loop I have already created the first column as well as the first row. So create the rest of the element. We have identified with our investigation that we need to use a for loop. And now for, let's say to make it easier for me to understand, I will use the variable r that stands for row. So how many rows I need? The rows number go from 2 until n. So this investigation will tell me that the row number go from 2 until n. Okay. In each row, I still need to run through the column number. Therefore, this tells me that under each row, I will have the column number will go from 2 to m. And under another row, the column number will go from 2 until m at this location. So this is the situation that let us know that we need a nested for loop. So before I write the inner loop, let me put the END so that I will miss out this END. And for the next one is the column number. So I use the variable C to remind me that this is about the column number. And the column number is from 2 until m. Therefore, it's 2 to m. And same thing, before I forget, let me add the END for the inner loop. Okay, so in these two loops, we will know for sure that we are going to run through all the elements that we have from this element until whatever element n and m that the user entered. Okay, so let's see what do we need to do for the element inside the loop. So by now, we have done with these two requirements, so we can delete them. And now we are going to write this part, the sum of the value above it and the element to its left. So let me put that over here because this is what I need to write. Okay, so that will complete this requirement. Okay, so now let's go back to this pattern that we have investigated over here. The first one is 2, 2. So, and I need to calculate the value for this element. Okay, so that means I need to insert a value into this location 2, 2. So therefore, I will be performing matrix addressing at the left-hand side of the equal sign. So I will put my mat equals to nm or mn, because I have already defined here that this is the row number. So I will start with row number, comma, the column number. Okay, and equals to the calculation. Now, just let me make a bit of adjustment so that this code is below the comment, which makes the code easier to read. Okay, what calculation that we need is the sum of the element above it and the elements to its left. So we have, this is the current element. So the sum of the element, that means we need to add two elements. One is the element above it and the elements to its left. So let's work on element above it. If I have this element, the element above it will be, let's check what is the position number of the element above it. So the element above it will be first row, second column. So that means we can compare this position number and this position number. We can see that the element above it, actually the row number is -1. So which means the element above it will be coming from the same matrix, but the row number is R -1 and the column number is still the same. So we can see from this pattern. Okay, the row number will be -1 and the column number will be the same. So this is the element above it and the element to its left. That means this element. The element to its left, let's investigate what is the number, the position of the position. So this is located in second row and first column. So we can see from here that in this case, the row number represents the same. So we can see in this case, the row number is the same, but the column number will be reduced by 1. Therefore, we will be able to write the code by using the same row number and the column number is -1. Okay, so I will put a semicolon because I do not want to display all the matrices from inside the loop. Okay, looks like I have done with this code. So let me run the program. And now I will just test with 5 rows and 5 columns. So the program seems to be able to run, and the variable my mat do have 5 by 5 elements. So let's check the contents and see if the code is written correctly. So you can compare this code 4, 7, 11, 16 to the sample given 4, 7, 11, 16. So it looks correct. The last value is 182. Then the last value is 182. So from here, we can see that we have successfully written a code that fulfill all the requirements given in the task 4S.